My name's Rich Warwin and I'm Head of Asset Intelligence and Innovation at Severn Trent. And I've been lucky enough to have this new role where I've brought together folks from across the digital, physical and biological innovation teams and brought them together with our asset data and modelling teams to create our new Asset Intelligence and Innovation organisation. So our framework has three core pillars to it. The first one is about protecting the business. So this is making sure that we're doing the things that our sub-services need to make sure we deliver against the performance and financial commitments that we've made. The second area is about enabling outperformance. So we don't want to just deliver what we've said we're going to deliver, we want to outperform. So identifying opportunities for us as a business and a team to support the sub-services and really making a difference and performing better than we originally planned. The third area is about transitioning to circularity. So for this is all about looking at opportunities to reuse, recycle all of the byproducts of what we do in our normal day-to-day businesses and turning those into new products that we can then return back into the economy and generate benefits for our customers and for all of our key stakeholders.
Spernal has been chosen as our model site for innovation purposes because it gives us lots of opportunity to work with different processes that are available on site. So it's got a history of being at the cutting edge of wastewater treatment. It's also a very interesting catchment and a useful works in terms of the number and the range of different processes that we have here. So it's a great place to start in terms of looking at what we currently do and where we need to be.
Our Resource Recovery and Innovation Centre at Redditch is a dedicated facility. It's the infrastructure for testing pilot scale technologies. There are 16 dedicated plug and play facilities to allow the trialling of any sort of technologies. We have the ability to use a crude sewage or settled sewage feed or import anything. So we centrate sludge, final effluent, and we can trial a number of processes in different flow sheets. We can have a primary treatment of one into a secondary treatment of another, and so and so. A unique point for this is all the discharge goes direct back into main site inlets. There's no discharge to the environment, so it's very, very safe. It's very flexible. We've got a dedicated biogas handling facility, chemical dosing, on-site lab, and dedicated innovation staff as well. So we work with the supply chain partners, universities, independent companies, trialling all sorts of technologies and all sorts of configurations in a safe environment.
So this trial is our anaerobic membrane bioreactor trial, where we're taking pilot scale work that we've been doing with Cranfield University over the last 10 years and supersizing it to Europe's first full-scale demonstrator of the technology. Treating wastewater is very energy intensive, and that's because we use air primarily to treat the organic pollutants within the wastewater. What this technology does is remove the need for treating air by using a different set of microorganisms that don't need that air to treat the wastewater. So in practical terms, about 60% of our energy usage in wastewater treatment is associated with that secondary treatment process. So if we can remove that need altogether by getting this technology right, we'll have a significant saving in our energy bills, but also reducing the amount of greenhouse gas emissions associated with treating wastewater. So as part of its planning for the last two asset management planning period, Severn Trent's been thinking about what wastewater treatment of the future looks like, and so we have our urban and our rural wastewater treatment strategy. So in our larger wastewater treatment plants, what we're looking to do is create resource recovery centres. So we see wastewater as a valuable set of resources rather than a waste that needs to be treated. What this is a key building block for that ambition. If you can treat the carbon and the solids without using any energy, it leaves you with a really clean stream of highly treated effluent that contains lots of nutrients, and that allows us to use different technologies then to capture that nitrogen and phosphorus in a form that's probably useful to other industries, so either the fertiliser industry or the farming industry or the chemical commodities industry. So the anaerobic MBR trial that we're running has been recognised in Europe as a kind of a leading edge building block for that kind of wastewater treatment plant of the future.
So this is part of our enhanced primary treatment trials. This is part of the low energy strategy. This is a microflotation unit, so it's similar to a dissolved air flotation process. It's more familiar in water treatment, and it's an advancement of the gravity settlement we used to use for primary treatment, which we'd use for decades basically. So rather than relying on gravity, it's dissolved air bubbles lifting sludge blanket to the top of the tank, which is then scraped off for processing. So what's exciting about this installation is we also look beyond traditional wastewater treatment technologies for our needs. For instance, this unit was originally used in the aquaculture industry. We're now using it for municipal wastewater treatment. It's an enhancement on old-fashioned primary treatment stage basically, and it produces a finer quality sludge, so we get much more of the recovery of the bound energy within that. It also has a much smaller footprint than other primary tanks, so in terms of an option for the future, it's a much more attractive option for a primary treatment on some of the sites which need either to increase the primary treatment size or being a new build altogether. It is really exciting. We get really good quality, very thick sludge without chemical addition. So it's very good for that sort of recovery, and we get similar removal of the pollutants, COD and suspended solids in a much smaller footprint and smaller retention time than the existing primary technology.
So what we're looking at here is our membrane aerated biofilm reactor trial. And a membrane aerated biofilm reactor is basically a very high efficiency way of treating the organic pollutants in wastewater, specifically ammonia. What we're doing is we're taking these membrane fibres and we're suspending them in the wastewater. What we're doing is we're blowing air down the hollow fibre centre of this membrane and allowing a biofilm to grow on it. That biofilm's really good at treating ammonia and also providing the denitrification of the nitrate that's generated from that ammonia removal. It's important to us as a company because we're looking into a number of sites in AMP7 where we've got really challenging tightenings on ammonia consent, and our normal way of doing that would be just to build more big concrete tanks and more aeration systems. So what we're looking for is a retrofittable technology that doesn't mean we don't have to pour more concrete and build more tanks. And this MABR has us really excited about that. There are two key component suppliers, Oxymem, who are a startup company from Ireland, and Suez. Because at Spernal we've got 3 lanes of activated sludge plants, we've got the perfect test bed to look at comparing and contrasting the benefits of both of these technologies. So we'll have a control lane where we can see what the normal activated sludge plant's doing, we'll have a Suez lane, and we'll have an Oxymem lane. Oxymem was installed about 12 weeks ago. It's already showing some fantastic performance in terms of ammonia removal. So the performance guarantee was somewhere between 7 and 15%. We're already up to that 9 to 10%, and now we're looking into a programme of work to optimise that to get us up to that 15. And we're really excited to see how quickly that picks up and then to compare and contrast the two systems. So it's a really exciting opportunity to look at two technologies side by side. It's not been done anywhere else in the world, and the companies have been very brave to sign up to that, to give us that opportunity to look at these two things as they come and establish why and how best they work.
At the moment we're looking at a lab scale trial looking at reactive media for phosphorus removal, which is a different way of removing phosphorus typically on the smaller sites. It's part of the rural strategy. It's much more of a passive system on sites with a newly consented phosphorus permit. Typically we rely on metal salts to remove phosphorus, but that we want to move away from reliance on chemical, part of the chemical resilience plan. This is a much more passive system that requires far fewer operational visits. This would replace media in the reed bed. So it all treats under gravity, chemical-free absorption of phosphorus, and fundamentally allows the recovery of the stored phosphorus as well. So that embraces our circular economy principles, and because it can be used for fertiliser. This has been running for about a year. We've had different media from different companies. We've had things like a recovered rock phosphate. We've had a produced calcite mineral with a sulfur dioxide coating. And they typically run for 8 to 12 weeks because we're looking at sort of breakdown of the media as well in the lab scale columns we have here. And we're also sending some of the samples away to external facilities to look at detailed mineralogy and also absorption over time to work out how long it would actually last in the field. It's really exciting because this is a completely different way of looking at removing phosphorus. It gets us away from the reliance on the chemical and all the associated assets and infrastructure. It's an entirely passive, much more holistic way of treating phosphorus for the future.
So we believe that this Resource and Innovation Centre is absolutely the biggest and the best facility of its kind in the UK. There's nowhere else like it. There's nowhere else that allows you to couple up different treatment processes and look at the process train, so primary and secondary connected together, secondary and tertiary treatment technologies. and see how those things interact. Historically, when we've trialled technologies, we've just looked at the technology individually and not how it fits into a process flow sheet. This facility allows us to do that at scale as well. So each of the individual streams that we run here are up to 2,000 population equivalent. And that's great for operations to be able to come and see those technologies under trial because they're at a scale that they will see out on site. But also because we're at a works that has 100,000 population equivalent of wastewater coming in, recycling whatever we treat or whatever we make a mess of back to the head of the works has no material impact on the performance of the works.
I think the R2IC has been a brilliant piece of investment, and it's really helping us now to trial and test some of those technologies that we're identifying. I couldn't be more excited about seeing new things appearing on the pad that we're actually testing and trialing so that we can really work out how they will deliver value to our business.